Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 366, I chat with audio legend Bob Carver about what he's up to these days. So stay tuned.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded August 10th, 2017. Episode 366, The World According to Bob Carver. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of AVSForum.com. This week's guest geek is audio legend Bob Carver, who has been on the show once before, but I really wanted to check in with him and find out what he's doing these days. Hey, Bob, welcome back.
Welcome. Thank you. It's good to be here. Of course.
So
always.
Nice. So nice to have you here. We're going to talk about a lot of interesting stuff today. But before we do, I want to make sure that everybody knows, those who are watching live at live.twit.tv can join the chat room, or at irc.twit.tv, and you can post questions as we go, and I'll pass along as many as I can. So, Bob, I wanted to start with your most recent products. You're known pretty well for amplifiers and speakers, and we're gonna go along both those lines. And your most recent products from your company, Bob Carver Corporation, are all tube-based. And so I wanted to start with getting your hit on why tubes are so important, and have been for you for most of your career, I think, as opposed to solid-state electronics.
I love tubes. I grew up with vacuum tubes. That's because I'm old, and I grew up with vacuum tubes.
You and me both, buddy.
Hey, it's not our fault.
That's not our fault, right?
No, it's not. So when I had an offer I couldn't refuse for Sunfire, and I took it, and then I didn't have a job. So I decided I would make amplifiers. What else? And I went back to my beginning and built tube amps, and I love it. And I love the sound of tube amplifiers. Mm-hmm. So that's the short answer.
Why is that? I mean, I think, would you agree with me that tubes are not, they aren't linear, certainly. They add distortion. They change the input signal. I've dubbed it desirable distortion. People really like the sound of tubes, and you're not alone in that. But it isn't necessarily what I would call accurate. And so my question is, what is it about tubes that make them so compelling and desirable?
Well, every amplifier interfaces with a loudspeaker, and the interface itself gives the amplifier sound combined with the loudspeaker a sound that is unique to that pair, sort of like a married couple. So we can have the personality. Right. We can have the personality of one person combined with the personality of another, and we have a third personality, and that's what happens. It's not the distortion; it's the way the interface works, and the interface with tube amplifiers is substantially different than the interface with a solid-state amplifier. And it was a long time ago. Harry Pearson noticed it. And I remember visiting him. Oh, this was years and years and years ago. And he said, "Bob, listen to this." And I said, "It's a tube amp." And I was building big solid-state amps at the time, phase linear. And he said, "Listen to this." And certainly it had a different sonic signature overall. So that's the reason. I don't know if I answered the question.
Well, yeah, you did go into solid-state for a while there with phase linear. And I guess with this meeting with Harry Pearson, found your way back to tubes, I guess, huh?
Mm-hmm. I did, but only recently. When I just started my tube adventure again. Recently,
right.
Years ago.
So we've had tube amps for a very long time, obviously. They kind of went out, and they're coming back. I know certainly there are plenty of musicians who still use tube amps and tube preamps in particular for things like guitars and so on to warm up the sound, right? And this gets back to the desirable distortion, which as two words put together seems like an oxymoron, but it actually does do that. I've always believed or thought that it was primarily the even order harmonics that were being emphasized a bit, which is what gives it the warmth and the sort of the desirable tone. I get your point about it actually being a relationship between the amp and the speaker, but would you agree? Am I correct in my understanding, or have I been thinking about it wrong all these years? That a tube amp tends to emphasize the even order harmonics, and that's what gives it that warm sound.
Well, it's true. It emphasizes the even order harmonics. However, those harmonics are very low level, and we don't hear them all that much. It's mostly the way it affects the loudspeaker's frequency response and damping factor, and the way it causes the transients to respond as a system more than the distortion components. The distortion components are pretty low. They're way less than 1%, substantially less.
I see. All right. But aren't digital amps, so can't you get distortion components, the distortion figures down way below that even?
Oh, absolutely. You can get them almost as low as we please. 0.0001, for example. Far less than a typical tube amp has about 0.25% distortion.
Right.
At full power, and even less. At normal listening levels, a tube amplifier has distortions usually 0.005, well below 0.1, which is transistor territory, solid state territory. At normal listening levels.
And you make a good point when you say at normal listening levels, because amplifiers, typically they're sold. One of the big selling points is, we've got this many watts, and they try to maximize that number. It's kind of a numbers game. But in reality, at normal listening levels, you're not using more than the first watt or so, right?
That's right. The first few watts.
First few watts.
Only if you're an animal with your volume control. Only if you're an animal with your volume.
Yeah,
more
and
sound.
If you do that if you do that for very long, you're going to have to keep cranking that volume level up more and more and more, which will give you more and more hearing damage. But that's a whole nother story. So where is tube amp design going these days? Is there anything new that you're working on in terms of tube amp design that has not been done before, or is now starting to be done but hasn't in the past? Well,
yes. One of the problems with tube amplifiers is that the tubes wear out in about 3 years, the output tubes. And and they're expensive. I mean, if you have a big tube amplifier, that's a lot of money for the output tubes. So I developed a circuit, and this is new, never been done before, to make the tubes last 50 years instead of 3 years. It's called the DC. Yeah. It's called the DC Restorer, and I actually didn't invent it myself. It was a circuit that was designed for television receivers. I was first exposed to a circuit like that when I was fixing television sets in my early 20s going to school. And I resurrected that circuit for the tube amps today. And so the output tubes now last about 50 years in my amps.
Wow. Well, that actually is an important question of tube longevity. And as you said, it typically was more in the 3-year range. This circuit makes it more in the 50-year range. What does it do to improve that longevity by so much?
It does it by reducing the idle power. Most tubes sit there idling away at about 25 to 35 watts, and the DC Restorer allows the tubes to idle at about 8 or 9 watts, or even 6 watts. And it also reduces the distortion by approximately the same amount. And the longevity of the tube is proportional to more or less the temperature raised to the 1.5 power, 1.7 I think it is. And that adds up to 50 years compared to 3 or 4 years.
I gotcha.
When you do the arithmetic. So, as a matter of fact, the tubes are so cool that you can put your hands on them while the amplifier is sitting there. You don't need a have to have a big cage to keep your fingers away from them.
Mm-hmm.
So,
which many tube amps have, because again, you want them for protection more than anything else.
That's right. So it's nice to have a DC restore reduce the distortion and simultaneously reduce the idling temperature and therefore the longevity.
Right.
And it works great.
And it's important, especially because tubes are getting harder and harder to find. Isn't that right?
Well, they were until vacuum tubes have had a huge resurgence in our industry. So many amplifier designers use vacuum tubes these days, and so they're available. They're readily available. There are 2 or 3 big manufacturers now that are making vacuum tubes. The Russian tubes are fantastic. As it turned out, before the Iron Curtain fell, they had a great tube factory. All their airplanes and all their military stuff had vacuum tubes in it because they liked vacuum tubes. They did, because they felt that the cosmic rays wouldn't hurt the vacuum tubes, but would hurt integrated circuits and transistors.
Wow, how interesting.
So they had a huge, beautiful tube industry that was just running along, and so they sold it to Electro-Harmonix because Electro-Harmonix said, hey, we'll buy your vacuum tubes. And they did. They bought all the, and the Russians make great vacuum tubes. I mean, military quality.
And those are now available anywhere in the world, probably thanks to the internet.
That's right. They are. You can get them.
Yeah.
In fact, if you want vacuum tubes, you can order them through the internet and have them in a few days. And the prices are far less, relatively speaking, than they were in the 60s here, believe it or not.
Wow. Well, I've got a couple questions in the chat room about damping factor. Digmax is asking, do tube amps have a higher damping factor helping to reinforce bass notes? Let's start with defining damping factor. So everybody knows what we're talking about here.
Okay, damping factor, technically speaking, is the ratio of the amplifier source impedance, that is, the amplifier driving something like a resistor or a loudspeaker, has an impedance associated with it, and it's usually about half an ohm to 2 ohms for a vacuum tube amp. And the loudspeaker has a characteristic impedance, and it's, say, 4 or 8 ohms. And so the ratio of those two resistance is the damping factor.
Okay.
So if
and
the
what
amplifier,
is...
I was just going to
Sorry,
give you
go
an
ahead.
example. Yeah, if the output resistance of the amplifier is half an ohm, the ratio of 0.5 to 8 is 16, so it has a damping factor of 16.
Okay. And what is the effect of the damping factor? What is its practical effect on the system?
It's actually quite enormous. It's one of the primary reasons that different amplifiers, each amplifier has a different sound when you hook it up to any given loudspeaker. It changes the bass, it changes the transient response, the distortion components change. So the combination of damping factor, the damping factor changes the combination distortion, frequency response, transient response, and probably a few other things that I could think about if I took a moment to think. But those are the main things, and they give a different sound to this loudspeaker.
Well, here we are right back to your first point about how the sound of an amp, quote unquote, really is the result of the relationship between the amp and the speaker.
That's right.
So do tube amps, getting back to Digmac's question, do tube amps have a higher damping factor typically than solid state?
Actually, a lower damping factor. The output resistance of a tube amp is usually a couple of ohms, whereas a solid state amplifier is a fraction of an ohm. So that means the ratio.
So what is that? The ratio is going to be lower with a tube amp because the denominator is higher.
Right.
So what effect does that have on the sound?
Well, let's say you take a big tube amp and you hook it up to a typical loudspeaker. The frequency response will change by it'll very closely track the impedance of the loudspeaker. So if the loudspeaker has a resonance at the low frequencies, which loudspeakers tend to do, it'll have more bass in that region, and the tube amp will therefore sound warmer.
Which is the typical description of tube amps. is
That's
they sound warmer.
It'll also have a little more energy in the mid-range. So it'll have sort of a beautiful mid-range, relatively speaking. Typically, the high end will be slightly subdued for a tube amplifier because at that point, the impedance is dropping for most speakers, and it'll follow that curve down.
That's one thing I think everyone should understand, that when you shop for speakers or you're looking at reviews or whatever, you'll see an impedance, one impedance number for the speaker, 8 ohms, 6 ohms, 4 ohms. But that's what we would more technically call the nominal impedance, that in fact the actual impedance varies by frequency. At different frequencies, the impedance of the speaker changes typically, right?
Absolutely. And a lot.
And a lot, yeah.
Yeah, it'll often give the loudspeaker the particular sound with a particular amplifier. So,
and this is all very interesting because, you read reviews of speakers, but that review really needs to take into account what kind of amplifier is driving it, because if you drive it with a different amplifier, you'll get a different kind of sound.
That's exactly right. Exactly. And it's substantial. It's not subtle at all.
Yeah, exactly. Wow. Okay, well, that's pretty cool. Let's see. Barfel is basically saying the same thing. Tube amps have a fairly high output impedance, so the damping factor ends up relatively low. Lawn Dog in the chat room is mentioning that amplifiers used to have the damping factor as part of the specs. Now he says he hears nothing about it. Have manufacturers kind of gone away from specifying that or talking about that?
They seem to have. The amplifiers of yesteryear not only had it as a specification, they almost always had a control on the front panel labeled damping. And you could turn it and the damping factor would go up or go down.
Oh, wow.
That's very interesting.
Yeah. So you could, in fact, affect the sound you were hearing because of the interaction between the speaker and the amp by changing the amp's damping factor. Presumably, it was some sort of potentiometer or something in the circuit that changed the output impedance of the amp.
That's right. And recently, Tim DiPerficini was asked what he thought the very best damping factor for an amplifier, and he said 1 ohm. That's high.
Why is that?
Relative.
Well, that's high.
Well, because it allowed a loudspeaker to have its own characteristic that he liked associated with the amplifier.
Wow.
It's got to be there.
Okay, so basically you divide by 1. So you're just looking at the speaker, the ratio, the damping factor is merely the speaker's impedance.
Exactly.
You know what? That reminds me of a parallel in the video world. And I know you're not a video guy, but I'll just mention this real quick. For projectors, I myself prefer to have a screen with a 1.0 or unity gain, because again, that lets you see exactly what the projector is doing. Now you need a super dark room for that. You can't do that in a light room. It has to be a very dark room. But if you have that, then you are seeing what the projector is doing, rather than any kind of manipulation that the screen might be doing if it doesn't have that unity gain. If it has more gain, the viewing cone narrows, you get hot spotting. If you have less than unity gain, other things happen. So, wow, this is quite an interesting parallel between audio and video.
That is interesting. And if you'd like to do an experiment and listen, if you're an audiophile and you want to listen to how things sound when you change something, go to the store and buy some resistors. Buy a 1 ohm resistor, a 2 ohm resistor, and half ohm resistor, and put them in series put them in the line between the amplifier output and the loudspeaker input. Put one of them for each speaker and listen. And you will be somewhat astonished, if you're not ready for it, how much different the sound will be each time you change it. You can't do it as a real life event because it takes too much power. The resistor absorbs too much power and you lose amplifier power. But you can listen to it and sort of enjoy an experiment.
Right. Lawn Dog is asking then, so why don't we see the spec for damping factor anymore, do you suppose?
I do not know. I just don't know. It's probably, manufacturers probably don't think it's all that important anymore.
You give it, of course, for your amps.
I do. I mention it. I do. In fact, it's part of the specifications. But it's archaic. I don't think anybody understands what its importance is.
Well, my audience now does.
Yeah, they do.
There you go. I Am Special is asking, what do you think of solid-state tube equivalents? Is there such a thing?
Say that again, equivalence?
Solid-state tube or valve, to use the British word for tube, equivalents. Is there such a thing as a solid-state component that is the equivalent of a tube or a valve? I mean, certainly transistor is, but it has a different character. I mean, it does the same thing. It switches current to go through it or not, but they're fundamentally different. And is there such a thing as a solid-state valve equivalent?
Probably the closest would be a field effect transistor, an FET, and that would be pretty close. The sound, though, depends on the circuitry, not the devices that make up the circuit, for the most part. And with careful design, one can be the same as the other. And from a black box perspective, you could make one indistinguishable from the other with some work. Sure.
It's a matter of simulation or modeling, if you wish.
Exactly.
I Am Special is asking, watt for watt, are valves or tubes louder?
A watt is a watt. It doesn't matter if it's from a vacuum tube or from a solid-state device. So 1 watt will sound as loud as any other watt. Or as soft.
Good point. Yeah. Yet another analogy I just thought of was calories. You eat a calorie of something, it's a calorie. Doesn't matter what it was. Some people talk about good calories and bad calories, but they're calories. That's all there is to it.
Yes.
Okay. My next question for you is amplifier topologies. We talk about Class A, Class AB, and we can. I don't mean this to be a class, so to speak, in amp topologies, but Class A is typically considered, sort of the audiophile standard, but it's highly inefficient. AB works a slightly different way. What are your preferences here? How do you like to design amps in terms of how they work with respect to the power supply, which is really what these classes are, what we're talking about?
Well, a little bit of history first before I jump into the answer.
Sure. Absolutely.
Years and years ago, when amplifier designers wanted to have a Class AB output or a Class B system for high efficiency, they couldn't do it because of something called notch distortion. And there would be a big discontinuity between the top tube, or the one tube conducting its job would be to turn off and hand the power to the other tube. And that's called push-pull. One pushes, one pulls. But it was so difficult that the only way to make it notch-free was to have a Class A amplifier. And a long time ago, that was the only way we could get rid of notch distortion. And its cousin called crossover distortion. And then many engineers around the whole world were working on this problem. And in the United States, a guy named Gordon Gow, who was Frank McIntosh's friend, figured it out, how to make an output transformer that would allow an AB loud drive system without notch distortion, and even without crossover distortion. And the high fidelity industry took off because we raised the power from about 6-7 watts to 60 watts, an enormous increase. So once that was developed, the high fidelity industry took off. Subsequently, and since then, there have been refinements in Class AB output stages to the point where they are absolutely as notch-free as a Class A. However, in the old days, the only way to get a nice pure signal was to have it Class A, and that belief system has held on till this day. It's not true anymore, but it's still there.
But a lot of people still believe it.
That's right. Old beliefs die hard. You know that.
Yeah, I do know that. I do know that.
Sometimes, anyway.
Just want to make sure everybody understands. So Class A, the waveform goes positive from 0 and negative from 0 and back and forth and back and forth. With a Class A amp, you have one amplifier doing all of that. With a Class AB, you've got part of the amp doing the positive moving energy and part of the other part of the amp doing the negative part of the energy. And it's that point where they switch off or hand off, as you said, that you can get notch distortion, you can get crossover distortion. But the amplifier designs today are, you can avoid those distortions. So do you do pure Class A or do you do Class AB in your current designs?
All Class AB.
AB. Because you can do it and it's more efficient.
Mm-hmm. And
exactly.
The way the crossover distortion was eliminated from a technical perspective is the A part of the AB, as well as the way the transformers wound. So a very special.
This was my next question for you. Yes, the output transformer.
I'm jumping the gun here, huh? Well,
no. You've segued perfectly.
The output transformer has to be wound a very special way, and that allows the amplifier to be operated in Class A during the transition period, as that sine wave that you were talking about transitions from positive to negative through that 0 crossing point. The amplifiers are operating in Class A, both of them, both the top one and the bottom is operating in Class A, and the way the transformer is designed, there is now no notch distortion at all. It's as if it was a pure Class A amplifier. But it's only Class A during the transition period, and then it switches to Class B and has all the efficiency that a Class B amplifier has. As I said, it's a big deal. 70 watts.
And that's because... Yeah, sorry. And that's because of the I'm sorry, pardon my interruption. That is because of the output transformer and how that is designed?
Absolutely. Along with the fact that the amplifiers are operating in Class A during the transition. It takes both.
Let's see here. Oh, this is very good. Terry K in the chat room is asking, is there a particular speaker technology that works best with vacuum tube amps since they are so interrelated?
Wow, that's a big question.
Yeah, I thought so, yeah.
That's a big deal question. Well, all loudspeakers have an impedance curve that varies with frequency.
As we mentioned before.
That's right. And if a loudspeaker does not have an impedance that varies with frequency, it will sound the same, exactly the same, regardless of which amplifier it's hooked up to, providing the amplifier has flat frequency response and low distortion and all that. So a loudspeaker will allow its own sonic signature to be exposed, to be brought forth with an amplifier if it has a woofer in it, if it has a mid-range in it, has a tweeter in it. So a loudspeaker has to have those three things in a crossover network, and that will allow the loudspeaker to operate with the amplifier in a very special way to give the sound that we want. So I guess that includes pretty much most loudspeakers, but not all. There are some that don't have those components.
Well, sure, there are plenty of two-way speakers, for example, that just have a tweeter and a woofer, and one crossover point instead of two crossover points. But still, the crossover, or even one full-range driver, yeah, exactly.
Right.
In which case, there's no crossover. That seems to me to be the most likely case of constant impedance over frequency, as opposed to multi-driver systems, which would have naturally different an impedance curve depending on frequency, particularly as you cross over from one to the other, right?
Exactly. Absolutely.
Yeah. Let's see here. Got a couple other questions for you. Tinker Toy Tech is asking, I used one of the Carver cubes on the top end from 500 hertz up, and a big transistor amp on the bottom end, a crown as it happens, for an exciting 2,000 watt potential loudspeaker setup. You must remember the Carver cubes. I don't remember the exact characteristics of them.
I do.
I'm sure you do. That sounded like an interesting idea. He's biamping there. He's amplifying the high end, the tweeter driver with your Carver cube, and then a bigger amp for the bottom, for the low end. What do you think about biamping and bi-wiring? This brings up a question that I didn't send you as part of the prep for this show, but it just occurred to me right now. What's your opinion on that? Taking a separate amp for the different frequency ranges of drivers, or even taking the same amp and sending it to each of these drivers separately?
It's a good idea if you need more power. 200 watt amplifiers will sound as if they are more powerful than a 100 watt amp if you biamp it, because it relieves, for example, the high frequency amplifier from having to develop lots of power, and so it won't use up all of its power, say, for driving the woofer if we're biamped. So it just splits the power up a little bit or substantially depending on the crossover. It's a good idea. There are diminishing returns once you have a big amplifier. For example, a 200 watt, 300 watt, 350 watt amplifier. At that point, it probably doesn't make a lot of difference sonically to have two versus one amplifier.
If you've got a high power amp to begin with. That's
right. So you won't run out of power when you wail on it.
Right.
It's called it's called the linear superposition of two voltages, and that's why it doesn't make any difference, really.
Can you expand on that a little bit? Linear superposition. I love that word. Those two words.
Well, a superposition simply means a special sum. When you sum two voltages together, they make a sum. And if both voltages are linear, the output, the resultant, is a superposition of two linear voltages, or a linear superposition of it's even hard to say, of two sums.
Yeah.
Or one sum.
Okay. All right.
Whatever.
All right. I got you.
Yeah.
I got you. Let's see here. Did we get another question here? Let's see. Oh, okay. Lawn Dog's got a good question for you. What speaker manufacturer or manufacturers do you believe produce the best sound in combination with your amplifiers? I'm not asking you to endorse anybody, and maybe you don't feel comfortable saying any particular manufacturers, which is okay too. Of course, you also make loudspeakers, which we're going to talk about in a minute, so maybe the question is moot.
Well, I also make amplifiers. So amplifiers. Well, there are so many good loudspeakers. I was my first loudspeaker love that was a complicated loudspeaker, relatively speaking, was a Dahlquist DQ10. I love the sound of Dahlquist DQ10s. I also loved the sound of Arnie Nudell's loudspeakers. They were incredibly complicated, but boy, they sounded great. The IRS systems, those loudspeakers that he developed, and let's see what else. Dahlquists, Infinities, the BMWs or BNWs. Those loudspeakers.
BMW, yes.
Yeah, BMW. It's hard to say sometimes. They have a nice impedance curve that matches my amplifiers, or any tube amplifier for that matter. I could go on and on, but you get the picture.
Well, yeah, actually, Lawn Dog is bringing up a point here, a related point. In the late 70s, Infinity speakers were known for their characteristic of variable impedance. Most speakers have variable impedance, but maybe these were more so than most, which produced their unique sound. And then they were coupled with, for example, an SAE amplifier. He says it's a fantastic combination in those days because he owns these products. So, there's another example of, the synergy between the amp and the speaker and the impedance curve of the speaker. All really important stuff. Let me ask you, another question is I'm reminded of in all of this is what are called active loudspeakers or self-powered loudspeakers, where the manufacturer designs an amplifier and puts it inside the box of the speaker. And you feed it a line level input and it does its own amplification. This has always seemed to me to be a good idea because you can optimize the amp for the speaker and the relationship between them. You take that flexibility away from the consumer or the person who buys it, but you gain something, it seems to me. What do you think about powered speakers?
Well, from the very beginning of time, they've been a great idea. Powered speakers have been the way to go. Every loudspeaker designer, sooner or later, comes along and comes to that conclusion. Let's put the amplifier in the loudspeaker. I can I can match them perfectly and get the sound that I'm interested in.
Yep.
The only problem has been not a technical one, but the marketplace doesn't want them. That's been the problem. So that's beginning to change these days, and probably has changed in the last 5 to 10 years or so. But usually the marketplace would reject it, a system like that, for no rational reason, except they just
I was going to say, why do you suppose that is? Yeah.
I don't know for sure, but I would imagine that it was because they wanted to have their own amplifier and have the ability to choose the amplifier that they wanted. That's what I think. I know that when I was presented with the notion of buying a loudspeaker that had an amplifier built in, I didn't want it. I wanted to have my own speaker that did not have a built-in amp. I want to build my own amp for it.
Well, you're an amp builder, so that makes sense.
I'm an amp guy, so.
And I do know that powered speakers are actually pretty popular in professional settings, recording studios, places like that. So, there is a place for them, but consumers, I agree, don't seem to want them so much.
That's true, and it's starting to change now. I think that notion that we should have separate speaker and separate amplifier is starting to change. Just as a separate amplifier, a separate preamplifier, separate signal source, they're all beginning to be combined now. Take a look. I mean, there's a unit out there that has the amp, the preamp, even has a signal source built in. Streaming.
Right.
You
have these integrated amps that have streamers built in and so on. Yeah, exactly. Well, let's take a look at some of your new current products that you have designed and are selling on your website. The 350 monoblock. I wanted to get a picture of that in there to show everybody. Tell us a little bit about this one.
It's a powerful amplifier. 350 watts has been my favorite power since my early phase linear days, which was a 700 watt stereo amplifier, 350 aside. So that's always been my favorite power level.
Why is that? Why is it? Why do you have a favorite power level?
I don't know. 350 watts.
It just happened to be what you liked. Okay, all right.
Yeah, 350 watts was a big power back in those days. It still is, but
Sure.
it was even bigger back then because who had a 350 watt? Who had a 700 watt amplifier? So
not very many people.
That's right. So after I sold Sunfire, I still wanted to build amplifiers, and so I built that just for fun. And I said, what power should it be? 350 watts. Poof. That was all. And 350 watts really is a nice power level, such that we can enjoy our music without worrying about amplifier clipping.
Right, and this was a point I think I was trying to make earlier, and I'm glad we came back to it, which is, as we said earlier, normal listening levels, you're only listening to the first few watts. So with a 350 watt amp, you've got, say, 340 watts that you're not even using most of the time. And that's the key, isn't it?
That's right. The peak to average power ratio of musical material is about 10 to 1. So worst case, 5 to 1. But anyway, 10 to 1 is a number that is pretty accurate most of the time. So if you're listening at 10 watts, you'll have 10 times more power needed for the momentary larger signals and the peaks and all that's associated with music or speech for that matter. So 10 watts becomes 100 watts, and that's conservative.
Right. And you still want room above that, what we call headroom, right? Because you don't want to drive the amp as hard as it can possibly go, because then you run into all kinds of potential problems, right?
That's correct. It clips and makes bad sound.
Very bad sound.
Very bad sound.
And then you have the Silver 700, which I love the name of that and actually the look of it as well. We think we have a picture. There it is. It ain't cheap for a pair of those things, $32,000. But man, oh man, 700 watts per channel.
I know.
Wow.
Each one is 700 watts. I always like lots of power.
You do like lots of power. That's very clear. Because not only do they have 700 watts, I mean, I think that's continuous RMS. They'll go even higher with voice and speech and music, as we were just talking about.
That's right. Even more.
Even more power. Remember that show?
More.
Now, will the 350 can drive 8-ohm speakers, 4-ohm speakers, even 2-ohm speakers, which are pretty.
Excuse me. Yeah, 1 ohms.
Yeah, go ahead. Even down to 1 ohm speakers. Are there any 1 ohm speakers? I don't think I've ever even heard of that.
Yes, there are, amazingly enough. One of the greatest sounding loudspeakers was called an Apogee Scintilla, and it was 1 ohm. Actually, they lied. It was less than 1 ohm. It's about 0.85 ohm.
Wow, and that's nominal. It could have gone lower than that in the impedance curve over frequency, right?
It could have, but it didn't. It was pretty much 1 ohm from left to right, all the way across the audio.
Oh, wow.
That was one of the exceptions I mentioned earlier. That was it was a ribbon loudspeaker, and there was no back EMF, no emotional impedance associated with it at all. Pure resistive, and it was slightly less than 1 ohm. And it took some heroic amplifier to drive it, like mine.
Yeah.
Or a big Krell.
No kidding.
You know?
Yeah. Yeah. Compy 386 is going 700 watts per channel. OMG. Lawn Dog asks, does that 700 watt amplifier, the 700 watt that we're just talking about, does that have a 50-year tube life? Have you done the DC restoration circuit on that?
Yes, I have. The original one didn't, but this one does. This is the one that I'm building now. That amplifier has evolved over years and years and years. Right. I hate to think about how many.
So, and the you mentioned different speaker impedances with the 350. In the specs of the 700 on the website, anyway, it doesn't mention different speaker impedances, but I assume that it can also drive 4 ohm, 2 ohm, maybe even 1 ohm.
Actually, it cannot drive 1 ohm as well as the 350 can, but it can drive 2 ohms better than the 350 can, meaning simply it delivers more power when I say better. Right.
Because as I want to make sure everybody understands, as the speaker's nominal impedance goes down, it wants more and more and more power from the amp. It allows more and more power to be drawn from the amp, and the amp had better be able to deliver it, or it's going to be in trouble. So this is an important part of amp design, if you ask me.
Yep, exactly.
Yep. What about efficiency? This was another question I had for you regarding tubes versus solid state. Is there much difference in efficiency? And by that I mean, how much power are they drawing from the wall? How much power are they delivering to the speaker? And how much power is being wasted or dissipated as heat?
Well, actually, this is interesting, but a solid-state amp versus a tube amp, the difference in efficiency is not much. Both are approximately, theoretically, about 78% efficient. The difference between a tube amp and
that's
a
with a
solid-state
Class
amp,
AB design. That's with
right.
a Class AB design. Yeah.
That's right. The tube amplifier draws some power to light its light bulbs up. It's called the filament power. It's about 10 watts per output tube. And a solid-state amp doesn't have that power to deliver. And also the standby idling current on a tube amp is usually higher than a solid-state amp. Not by a lot, but it is a bit higher. And so, except for the filament power and the slightly increased idling power, they're both about the same efficiency. Plus, there's some losses in the output transformer, but not much compared to the general overall inefficiency of an amplifier. They're both about 78%.
Wow. I didn't realize that. That's pretty cool. Lawn Dog in the chat room is asking, he's remembering fondly a CD player that I guess you made at one point with tubes in the preamp stage. And he's bemoaning the fact that it was discontinued. It is a highly sought-after CD player. What was your thought there? Not about discontinuing it. I guess that might have just been business or whatever, but putting tubes in a CD player, really?
Oh, I love vacuum tubes. I remember I grew up with vacuum tubes. I love vacuum tubes. I wanted to see a vacuum tube in everything I ever made, but there were practical reasons. I loved walking past the assembly line and looking at a nice 12AX7 in that CD player. So I put it in because I love vacuum tubes. And
now, and what did it do to the sound? Again, I guess we're getting back to the sound of tubes.
Yeah, it changed the sound a little bit. Of course it did, because it had a vacuum tube in it. Yeah, and a lot of manufacturers are doing that now, and a lot of designers like to put a vacuum tube in there. I did it because I like the looks of a vacuum tube glowing in the evening.
How interesting. You did it as much for visual aesthetics as audio or aural aesthetics, huh?
I did. It was an artistic expression of my desire for vacuum tubes. And, of course, it did shift the sound a bit, too, toward the typical tube sound. That was nice.
Well, Lawn Dog is very sad that it was discontinued. So maybe you might think about bringing it back.
Well, there was a story about that when we decided to build that CD player. My marketing guy said, "Nobody wants tubes, Bob. Are you kidding me? Come on, let's." And I said, "No, I want tubes in there." So we went back and forth, and we decided to do two of them. They were both identical CD players, except one of them had tubes in it. So we built them both, and guess what? Everybody wanted the tube one, not the solid state one.
How interesting. Was that with Sunfire?
No, that was with Carver.
Carver, okay, before Sunfire.
Before Sunfire.
Yeah.
I thought that was interesting.
Lawn Dog's, very interesting. Lawn Dog says it was thought to smooth out the digital transients that everybody complains about in CDs and digital music as not sounding natural. And I guess that would bring up the question of applying tubes to to an all-digital system, streaming or CDs or digital files stored on a server or something. Do you subscribe to the notion of, hey, you put some tubes in there somewhere in this signal path, you're going to smooth out that digital, what some people call digital harshness? What do you think?
My experience has been, my thoughts on it are incomplete, because my experience has been that if I put a vacuum tube in a circuit, and it can be a simple inline vacuum tube in the signal path, and I hook it up and listen to it, I like the sound of it better than if I don't put it in. And yet, and it's a very powerful, powerful feeling, but that's only if I know it's there. When I've done experiments, when I've done a series of converging experiences to teach me what's really going on, it's far more difficult to know if I don't know which one I'm listening to. Extremely
interesting. So it's expectation bias, and doing blind testing gets you to recognize that objectively, if you can call it that, things are much closer than if you know what you're listening to.
That's exactly true. And yet, if I have the choice, I will listen to the one with the vacuum tube because it just makes me feel happier inside. I know it's going to sound better. There's some part of me that just knows that. And yet, often objectively, with a scientific test, it doesn't come through. But that's what audio is all about. It's emotions, you know?
Yes, and isn't that true? Isn't that true? Audio is all about stirring the emotions. And so can hardly be called objective in that sense anyway. Well, listen, in the little bit of time we have left, I want to turn our attention to your speakers. Now, you have these speakers called the Amazing Line Source speakers. And we have a couple pictures of them, actually, we want to show people. There they are right there. And also in a room, and I want to show that picture in a room. Those things are tall. Man, they go floor to ceiling. Tell us a little bit about these. What's the idea behind them, and how you came about coming up with the Amazing Line Source speakers?
Well, first of all, the name. I wanted them to have a name that was impossible to pronounce without aggrandizing them. So that's why.
A true marketeer there in that moment, yeah.
Now imagine those loudspeakers in this room. Imagine the floor is a mirror and the ceiling is a mirror, and imagine that all the little drivers in there. Just imagine them being little candles or little light bulbs or something. And if you look down at the bottom, you'll see a loudspeaker with little candles that goes all the way down through the floor. Remember, it's a mirror, and it'll go down to minus infinity because it uses the top mirror, the mirror that's represented by the ceiling. If you look up, you'll see a line source with speakers and candles or light bulbs that goes all the way to plus infinity. It behaves as if it's a long gossamer wire that somehow, by magic, makes sound. That's what a line source does. It actually behaves as if it goes all the way down and all the way up to plus infinity and minus infinity. And guess what? Each one of those they're called image, in this case, loudspeakers, produce sound, just as much sound as the one that's actually there. And you can if it were light bulbs, you could read a book by it. You can actually listen to those speakers. And they produce a sound field that is unique among sound loudspeaker reproducers. And it gives a soundstage that's impossible to achieve any other way. You get a big, huge, beautiful, realistic soundstage, and the forward-firing ribbons produce the images, the solid images, within that larger acoustic, within that larger soundstage. So that's the fundamental way they work. I love ribbons. I love ribbons, and I love line sources.
We should say... Look, I was just going to say, before we go any further, let's take another look at the first picture and zoom in a little bit so we can see the structure. There are these tall, thin structures, towers. They have ribbon drivers all along the front, and they have, I guess, what we'd call mid-range dynamic drivers on both sides facing outward. We actually have a cutaway from the top that we can take a look as well. To see what it looks like if you were looking straight down on them, you would see kind of how the structure is called ALS cutaway or top cutaway, something like that. I forget exactly what it's called. There it is. So this is looking straight down from the top. And what led you to this design?
It was a lot of things, actually. It was a long set of experiments that taught me that if we want to build a big space, we can easily do so by having drivers that make sound go out all around the loudspeaker. And that's what the side-firing drivers do. They do two things. They provide something that's called an interaural time delay. The spacing of those drivers is about the same as the spacing between our ears. When we hear sounds in real life, we always hear two sounds per sonic event. So if you snap your fingers, your left ear hears the snap, and so does your right ear. When we play it back with loudspeakers, though, we hear four sounds, or 4 arrivals for each sonic event. It's not quite as realistic. And what that does is the incorrect number of sound arrivals into our ear brain causes the space to collapse. So by doing this, by having this arrangement, I've recovered that lost space. It required 2 drivers, spaced apart about the same as our interaural time delay, and it required a set of drivers that lit the room up to make the larger acoustic. The ribbons put the images inside of that larger acoustic, and that was the effect I wanted, and these speakers deliver that.
Let's show the picture that I sent up to Josh of the interaural time delay, ALS interaural time delay. So here's what you were talking about. They're separated by about the distance between 2 ears on a head. You say the time delay between them is about 100 microseconds. I think that says there, right?
Yeah, and it does say 100 microseconds, and I think it's wrong. I think it's more like several hundred microseconds.
Okay.
The speed of sound is about 1 foot per millisecond. Our ears are about 6,
Right.
7, 8 inches apart. So I did my calculation wrong. I just did it for the picture this morning, and I got it wrong. Sorry.
Well, thank you for putting a picture together for me. We also have one called imaging in acoustic space, I believe, so we can see kind of what you're talking about. Here we go. Tell us a little bit about this picture.
Well, that shows the wavefront propagation associated with the ribbons in front, and it shows also the wavefront propagation associated with the side-firing drivers. The ones that are going around and around generate an acoustic space. And I'm labeled those acoustic space sound waves.
Mm-hmm.
And that, if you kill the ribbons, if you're listening to the speaker and you turn the ribbons off, you're left with a large acoustic space, and the frequency response of the side-firing drivers goes up pretty far. It goes up to about 15 kilohertz, 12 to 15 kilohertz. So
wow,
they go up very far, and it makes a beautiful space. But that's not the end of making a loudspeaker work properly. It has to put images within that space. So it has to have good imaging. That's where the ribbons come in. They make sound waves that allows the loudspeaker in total to define images inside of that larger acoustic. So if we listen to the loudspeakers, we can close our eyes and hear individual instruments and their physical location with great accuracy. And at the same time, we hear the side-firing drivers enhance the ability of the loudspeaker to make a large, believable acoustic space that's real and believable and sounds delicious when you listen to it.
I would think that the acoustic space basically the sound coming from the side-firing drivers might interfere with the space coming from the other speaker. If you have 2 of them, is that a concern, or do I not quite get it?
Nope, that is a big concern, and I worried about that, and I worried about that a lot when I was designing these speakers. And I had built a theoretical approach to the speakers in my mind before I actually built it. I was very worried about that, and especially because I had 2 sets of side-firing drivers displaced in time about, I think it's the real numbers, 600-700 microseconds. And I worried about that. I worried about all those interferences, and because I was taught that we should never build a loudspeaker that had those problems, quote unquote. I built it, and I was stunned that those problems didn't manifest themselves in any way, shape, or form. In fact, the manifestation was they sounded more realistic rather than less realistic. And I knew it almost immediately when I built them and fired it off for the first time. I didn't even have a crossover. I just let her rip, and I was listening for the spatial effects and perhaps the interference effects, and they didn't exist. And they don't exist apparently because of the way our ear-brain system works. It actually sounded better, and a little bit of thinking taught me And I did some experiments to determine what really was going on. But apparently, our ear likes multiple sound arrivals. It just does. And with multiple sound arrivals into our ear brain, we are able to build a believable image of the outside world. And if those are taken away, as I've been taught they should be when we design loudspeakers, the image tends to collapse, and it doesn't sound as beautiful, as big, nor does it sound as realistic. And I was sort of I was taken aback. I think probably
there you go, experimentation.
I was going to say, I bet Amar Bose understood that early on.
Yes, of course. Founder of famous Bose Corporation, recently passed away a year or two ago, right?
Yes, he's gone now.
Yeah.
I didn't personally.
You didn't know him?
Nope.
Terry K is asking, makes me wonder if this creates a kind of a reverb effect, but I think from what you're saying, it doesn't.
No, it does not. There's no reverb effect. For reverb effect, the delays have to be a lot more than a few hundred microseconds. A lot more.
Right. I Am Special is asking, so the left and right channel in both speakers? The answer is no. You get the left channel audio goes to the left speaker and the right channel audio goes to the right speaker, right?
Right.
Yeah. I wanted to talk a bit about the directivity or the sound field created by these speakers. And one of the reasons that line arrays are so important, I think, and correct me if I'm wrong, is that they have sound fields that are more even. They don't extend up and down very much. So you're not getting a lot of floor bounce or ceiling bounce, correct?
That's right. And the reason is the loudspeaker makes the floor go away and makes the ceiling go away. Remember what I said a minute ago? Pretend that the loudspeaker floor, that the loudspeaker's on, is a mirror, and so is the ceiling. And imagine that all of those drivers are little light bulbs. And you can imagine this visual experiment in your mind. If you look at the floor, it's a mirror, remember? And the loudspeaker has light bulbs that go down, 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 way below the floor.
Toward infinity, because they're reflecting back and forth between the ceiling and the floor.
That's right. And for sound, the floor doesn't have to be a mirror. It just has to be a solid place. And that's the way it works. So there are no floor reflections. There are no ceiling reflections. And that makes it sound better. Right.
I just wanted to make sure we touched upon that, because that's one of the characteristics of line arrays that you have obviously taken great advantage of. Now, the amazing line source speaker doesn't necessarily go down that deep, right? I believe the bottom is 75 hertz or 65 hertz, something like that.
Something like that, yes. And a subwoofer.
So you ship with a subwoofer called the Sub Rosa, great name, and we have a photo of that as well. And so one of those comes with a pair of these speakers, right?
Right.
So you obviously are of the camp that subwoofers are okay. There are audiophiles who say, and I've heard them say it, you only want two full range speakers that go all the way down to 20 hertz, all the way up above 20K. And I don't want any subwoofers. I don't want to have to deal with blending them with the main speakers or positioning them or anything like that. You're not of that camp, right?
No, I like bass. I like lots of bass.
Well, there are full range speakers that produce plenty of bass.
Well, actually, if you have a full range speaker that has bass, the voice coil has to be big and heavy. There'll be something amiss in the upper frequencies that it won't be able to produce properly. At least the ones I've seen. I've never seen one that could really run full range with a lot of output and take a lot of power. They've been pretty wimpy, actually. And I like power. Okay. I like power. I like bass.
Yeah, power, like bass.
And I like imaging, and I like sweetness, so it's not, from my perspective, it's not all that practical to make a full range speaker, especially if you're going to take it down to 18 hertz. It requires a special
which these guys do. They go down to 18 hertz. And, you know, I am not of that camp either. In fact, I believe that having a separate subwoofer is important because that lets you place the subwoofer, one or more of them, where they are best suited in the room, which might not be, in fact, typically isn't the best place to put your main speakers, right?
Absolutely. Yes.
So that gives you it gives you more flexibility to really optimize the sound. What about stereo subs? This was another question that always comes up. Even if whether or not you have these true full range speakers, or let's take your approach, which I agree with, of having two main speakers and two subwoofers. Many people say bass is non-directional. You can't really localize it. So why do you need two subs?
That's a very interesting question, and you're right. It always comes up. It comes up again and again and again.
Yep.
Don Keel did and he's a subwoofer guy. He did a set of experiments years ago to find out whether it's better to have one sub or two subs. He found that you can always get, or at least I think that's what he said, that you can get the same performance with one sub if it's judiciously placed and if it has enough controls on it to make booms go away, for example, an equalizer or something. If the room is causing a suck out or makes a boom at a certain frequency. Now, with two subs, you have much more power output, obviously, double the power output. And it also will smooth out room variations. Typically, two of them will smooth out some of those variations.
Yes,
according to Don Keel, exactly. So it's much easier to get a smooth bass response if you have two. But according to Don Keel, you can get it in another way as well with one sub by carefully installing it, carefully positioning it, and you have to do many more experiments apparently to get it right. So Don Keel knows a lot about subwoofers.
Well, and isn't that interesting? Isn't that interesting? Because he is scheduled to be a guest on this show next month.
Oh my goodness! Say hi to him for me.
Yep, I will, and I will definitely ask him about this because it's a really important question. He also does some work in line array speakers as well, so it's going to be really interesting to hear what he has to say about them. And I will certainly ask him a lot about subwoofer placement and one versus two and that sort of thing. So,
and I'm going to be watching.
I'm sorry?
I'll be watching the show.
Excellent. Very good. Yeah. Well, listen, we've come to the end of a fascinating hour. Time goes so fast when I'm talking with you. I want to thank you so much for being here.
Oh, I thank you so much. It was a pleasure and a joy. We can do it again.
Yes, well, I look forward to it very much. That's Bob Carver, audio legend. He's been around the business for a very long time, and his most recent...
Where?
His most recent incarnation is at Bob Carver Corporation. That's Bob Carver Corp, CORP.com. And that is the website where you can find much more information about what Bob's doing these days. So I do encourage you to go check that out. And Bob, thanks again.
Oh, thank you. Pleasure.
You can always find... Oh, mine too. You can always find me at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/HTG, and on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, I'll be on vacation. So I'm pre-recording the podcast for next week, tomorrow, Friday, August 11th, from 2:30 to 3:30 p.m. Pacific time. And so I do hope you will join us for that. My guest will be Bob Schuline, who does a lot of work in 3D audio and binaural recording. And we're going to be talking about applying that to virtual reality applications. So that's going to be really interesting. And I do hope you will join us, and by all means, come into the chat room and converse with us and ask questions, and I will pass those along. But that's tomorrow, Friday the 11th, 2:30 to 3:30 p.m. Pacific time. I do hope you will join us then. Until then, geek out.